Beyond the edges of what we see, there lies an infinite universe, an endless tapestry woven with threads of light and shadow, a realm where hope flickers like distant stars, and dimensions beyond our perception ripple in silent harmony. In this vast, silent dance of creation, the universe whispers its secrets through cosmic timing, guiding, shaping, and sometimes warning us. It is a language of patterns, rhythms, and subtle signals that, when understood, can reveal the path to success or warn of impending failure. After the success of the Axiom 4 mission, I faced my next challenge, a metaphorical climb of Mount Everest alone, guided by the universe's will. On June 25, 2025, I learned that NASA and ISRO were collaborating again on the NISAR mission, with a staggering program cost exceeding $1.5 billion. Instantly, I knew this would be my next focus. Once again, they had chosen an inauspicious launch window. This time, I reserved my energy and issued a straightforward advisory. $1.5 billion is at stake. I guarantee with absolute certainty, probability 1.0, that the currently scheduled launch date for NASA and ISRO's NISAR mission is extremely inauspicious. If you'd like to safeguard national prestige and avoid unnecessary costs, please reach out. This rocket will not lift off as planned on July 16, 2025. Nothing auspicious if it is forced to. I limited my outreach to key figures: the Prime Minister of India, Narendra Modi, and the President of India, Shri Draupadi Murmu. I also posed the same challenge as before. 1. Hold the currently published T0 of 5 p.m. IST on July 16, 2025. 2. Conduct the countdown and launch exactly as planned, without modifications based on my astrological counsel. 3. After launch, make mission performance data, on-time liftoff, vehicle health, orbital insertion accuracy, etc., publicly available so that interested observers can evaluate the outcome objectively. If the mission proceeds nominally, the result will underscore the robustness of modern engineering and operational discipline. If significant anomalies or additional delays arise, the data will strengthen my track record to suggest that astrological timing considerations deserve a closer look. Either way, the space community and the public will benefit from an open, evidence-based comparison between science and astrology. I remain fully committed to celebrating a flawless flight and stand ready should the need arise to propose an alternative, astrologically favorable window that aligns with all mission constraints. I heard nothing until a severely triggered ex-user, an ex-ISRO engineer who had worked on NISAR, attacked me personally. He accused me of nearly blackmailing with astrology, mocked my tweet about saving NISAR, and dismissed my timing warnings. He praised the NISAR team's hard work and prayers, insisting they'll be rewarded regardless. He arrogantly claimed to be the biggest believer in Govinda and Krishna more than anyone on Twitter, while simultaneously condemning astrology as pseudoscience and organized crime. He sarcastically suggested that instead of satellites and science, we should just hire Vijay Jyotish, a godman who can do everything without technology. He compared astrology to scam calls, calling it organized crime, and dismissed it as pure deception. Things escalated further when he tagged a personal post from my formative years, mocking my earlier fascination with missile aerodynamics and my aspirations to work at Raytheon or Northrop Grumman. He sarcastically expressed relief that I hadn't joined those companies. At that point, I decided to stop holding back. It was absurd for ISRO and its engineers to be deeply religious and devoted to Krishna, yet dismiss, insult, and despise astrology, both emerging from the same spiritual traditions. I felt it was my duty to deliver that karmic lesson. On June 30th at 8:52 a.m., I published my respectful yet firm forecast. Pilgrimages to Sri Venkateswara at the Tirupati Hill Shrine, often paired with a stop at Chengalama Temple in Solarpeta, are woven into ISRO culture. Engineers regularly present miniature launch vehicles, seeking blessings for clean engine starts and perfect staging. The ritual never conflicts with calculus or telemetry, it complements them. Yet a contradiction emerges. The temple visit is welcomed, but the astrological timing counsel that flows from the same tradition is set aside. That selective respect will prove costly. If this advisory is ignored, if the analysis is dismissed or mocked, no procession up Tirumala's 3,550 steps will rescue the mission. The GSLV Mk2 will not lift off at 1700 hours IST. A countdown hold, scrub, and reschedule stand at probability equals 1.0, certain. Should the team nevertheless force a liftoff simply to prove this forecast wrong, the flight will be non-nominal. Guidance faults will arise, orbit insertion will miss the mark, and the result will be the loss of the launch vehicle and/or the $1.5 billion satellite. Even partial survival would leave NASA, ISRO, and NASA JPL NISAR unable to meet its science objectives. Below are the only fault paths highlighted to date. No more, no less. Probabilities are attached. Each is now rated high. Electrical power system undervolt. Probability approximately 0.8, high. Weeks on the pad let individual battery cells drift. At least 4 minutes before liftoff, T minus 4 minutes. The avionics self-check will detect low voltage on the 28-volt bus and command an automatic hold. Batteries, especially those used in space missions, are sensitive to environmental conditions and usage patterns. Over time, slight imbalances in charge levels among cells can occur, leading to a cumulative effect that reduces the overall voltage. This is often referred to as the battery butterfly effect, where small initial drifts can lead to significant capacity loss over time. At T minus 4 minutes before liftoff, the avionics self-check is designed to detect such low voltage conditions. If detected, it will automatically command a hold to prevent potential failure during the critical launch phase. This is a safety feature to ensure that the electrical systems are operating within acceptable parameters before proceeding. Cryogenic fuel temperature imbalance, Kwananan, Krashiri Kitui, probability approximately 0.8, high. Liquid hydrogen, LH2, cooled even 0.8 Kelvin too far, can turn slushy, while liquid oxygen, LOX, may stratify. Engines will read the wrong mixture ratio and shut the start sequence within milliseconds. If LH2 is cooled too much, e.g. 0.8 Kelvin below the optimal temperature, it can turn slushy, which affects its flow and combustion properties. Conversely, LOX can stratify, meaning it separates into layers of different densities, which can disrupt the mixture ratio required for efficient combustion. The engines are designed to read the mixture ratio of fuels. If the ratio is incorrect due to temperature imbalances, the engine control systems will shut down the start sequence within milliseconds to avoid catastrophic failure, such as an explosion or inefficient thrust. Ignition sequence, mistiming, or probability approximately 0.80 high. The hypergolic igniter pulse and main valve opening must align within approximately 30 milliseconds. Any slip will prompt the controller to abort, avoiding a hard start overpressure event. Hypergolic igniters, which ignite upon contact with the oxidizer, and the opening of main valves must occur within a very tight window, approximately 30 milliseconds. Any misalignment can cause issues. If the timing is off, the controller will abort the launch to prevent a hard start overpressure event, which could damage the engine or the entire vehicle. This is a critical safety measure to ensure that the ignition process is smooth and controlled. Vent and pressurization valve stiction, probability approximately 0.8. High. Ice collars can lock a gaseous nitrogen, GN2, vent or a helium pressurization valve. Tank pressure will drift outside limits. Flight software will veto continuation. Cryogenic environments can cause moisture in the air to freeze, forming ice collars around valve mechanisms. This can lead to stiction, static friction, where the valve fails to move as intended. If a vent valve for GN2 or a helium pressurization valve sticks, it can cause the tank pressure to drift outside acceptable limits. The flight software, designed to monitor these parameters, will veto the continuation of the launch to prevent potential explosions or other failures due to improper pressure management. Guidance and sun synchronous orbit injection error, Kishi, probability approximately 0.8, high. If launch proceeds regardless, Inertial reference drift and star sensor dropout will corrupt guidance. The upper stage burn will significantly miss the required sun-synchronous orbit plane. Recovery delta V will exceed onboard propellant, dooming the satellite to an unusable orbit or outright loss. Inertial reference drift, where the inertial navigation system loses accuracy over time. And star sensor dropout, failure of sensors to track stars for orientation, can corrupt the guidance system. This affects the upper stage burn, which is crucial for achieving the correct sun-synchronous orbit. If the upper stage burn misses the required orbital plane, the satellite will not be in the correct orbit. The recovery delta V, change in velocity needed to correct the orbit, would exceed the available onboard propellant, leading to an unusable orbit or total loss of the satellite. This would render the mission a failure, as the satellite would not be able to perform its intended scientific observations. And as you might have already guessed, I was right once again. My advisory, issued for a 16th of July 2025 launch at 1700 hours Indian Standard Time, stated unequivocally that the GSLV Mark II would not leave the pad at that moment. A hold, scrub, and reschedule were described as certain. Reality has now caught up. First, the Telugu Daily Inadu Net suggested 18 July as a new date, and soon after Deccan Chronicle reported an even later target of 30 July 2025 at the same 1700 hours Indian Standard Time. NASA spaceflight's high reliable schedule calendar has also rolled over to the new slot, while the original 16th July window has vanished. The core forecast, the announced T0 will not happen, is therefore confirmed. Because the attempt was scrubbed in its entirety, the mission never even entered the T4-minute terminal phase, where I had warned electrical bus undervolt or valve stiction faults would surface. The pad stayed cold. The stopwatch never reached the critical point. Again, that is exactly the kind of countdown hold scenario the advisory anticipated. The outcome reinforces my documented record of time engineering accuracy, already demonstrated on Axiom 4, GSATN-2, Chandrayaan-3, Falcon 9, Starship, and other campaigns. NISAR's slip simply adds another data point to a chain in which forecasts grounded in Muhurta analysis have outperformed published manifests. In short, NASA and ISRO have conceded the match. The forecast said no go, and the launch slipped exactly as predicted. A detailed assessment of the provisional 30th July opportunity will follow shortly, and I can already hint that the heavens are not yet satisfied. In the vast silence of the cosmos, where patterns and timing hold the key to success or failure, we are reminded that science and tradition are not enemies. They are two languages speaking the same truth. The universe whispers its secrets through cosmic rhythms, and it is our duty to listen. When we ignore these ancient signals, we do so at our peril. Let this be a lesson. Whether through the equations of science or the signs of the stars, the universe always has the final say. And in that cosmic dance, those who heed its call can truly transcend the limits of human achievement.